So today we are starting a new chapter of mensuration, okay, surface area and volume. And before that, I'd like to ask that do you face any issue or any problem in your arithmetic progression? No doubts. Okay, so the topics that we are going to cover in the surface area and volume are the some important formulas. The main thing in the surface area and volume, the main thing is that you should remember the formula. Okay, you should remember all the formula by heart. So after we'll discuss all the formula in today class only. Okay, after that make a chart, a small chart paper, take a chart paper, write all the formula and pin it down where you study, near your study table or wherever you study. Okay, so that you can see every time that formula. Okay, at least once when you see also daily na, then you will remember that formula. Okay, it's all about formula and calculation. Okay, if you know the formulas, if you remember the formula correctly, okay, and your calculation is nice and good, so you're not going to face issue in your surface area and volume. Okay, so formula is an important part in this surface area and volume chapter. Okay, and one 6 marks question comes from this chapter. Okay, and I think one 4 marks also. Okay, so 6 marks question is going to come, so you have to, and generally the question comes from the combination of a single object and the not there. Okay, and moreover the frustum may be there. Okay, a chances of frustum is 50%. Okay, and other questions can also be there, but one question will be there. So remember the formulas. Okay, so now we are going to, apart from the important formula that is the main part of this chapter, the three topics that we are going to cover: surface area and volume of combination of solids, means we will be seeing the different types of questions. Okay, that how the two surface can be combined, and then you have to find out the combination of the solid. Okay, volume and surface area and all that. Okay, now conversion of solid from one shape to another. Many times the solid, a metal solid is there, and we are going to melt that and going to change it into another solid. Okay, so the same volume, the same will be there, and which what will be the size of the new shape. Okay, so you have to find out all that. Okay, and the third one will be the frustum of a cone. Okay, frustum, a cone is there. In frustum you cut that the pointed part, and that is called, that structure is called a frustum. Okay, and this is an important topic. Frustum, this is an important topic. Okay, it's not that the other are not, but it is most important. Okay, now let's see. First we'll see the common definitions here. Okay, that you are already well aware, but still will be just quick discussion of that. Okay, and if you feel any doubt in any of the definition, you can clear it. Okay, so till now you have already been calculating surface area, the area of a square, cube, circle. Okay, we have seen the circle chapter also, area, but this time we are going to see a solid figure, a three-dimensional figure. What is the difference between a three-dimension and two-dimension? Okay, in two-dimension, okay, when you are dealing with a two-dimensional figure, it is just a plane. It is on the plane. Okay, so area will be there, volume will not be there. When volume comes in place, when there is a three-dimensional figure. Okay, a cube. Okay, and here the surface area is also little different. Okay, because here so many faces are here, only not, it is not in a plane. Okay, this is a 2D figure. Okay, and this is a 3D figure. Okay, okay, here apart from length and breadth, height also comes into play. Okay, height is also there. So you have a, like your room, okay, in which you are sitting, it can be a cuboid or a cube. Okay, you can see there's four walls, a floor and a ceiling. Okay, so it is a three-dimensional figure. It is having a volume, it is having surface area. Okay, now let's see, then I will explain that in detail. Solid figures. Okay, the objects having definite shape and size and occupy a fixed amount of space in three dimension are called solid. Okay, everybody knows solid, liquid, gas. Okay, solid is going to have fixed dimension. Okay, you cannot change the dimensions. Okay, and what are the solid figures that we are going to study also in this chapter? That is cube, cuboid, cylinder, cone, sphere, and hemisphere. Okay. Cube and cuboid. Cube is the three-dimensional form of a square. The cuboid is the three-dimensional form of a rectangle. Cylinder. If you're going to rotate, I'll explain you. Rotate a rectangle in a circular form. Okay, then you form a cylinder, a cone, and if you're going to cut that cone from the top, you'll get a frustum. Sphere. If you're going to cut the sphere into half, then you'll get a hemisphere. Okay, like circle and semicircle. Okay, now what is the surface area? Surface area means just the area of the surface. Okay, surface area of a solid body is the area of all its surfaces together, and it is always measured in square unit. Okay, remember this, the unit also plays a, if you write the wrong unit, then half marks you will be cut. Okay, so remember the unit also. Okay, so the surface area you'll get in square unit, and it is the area of all the surfaces, like the room that you are sitting in. What will be the surface area of that room? Your four walls, the area of the four walls, the ceiling, and the floor. That is the surface area. Okay, understood? But if I'm talking about the volume of that same room, then if you're going to fill that room, the whole room, with something like air, it is always, if something is there or not, air is there. So how much air can be used to fill that, or how much air is there which is filling that room? That is the volume. उस पूरे room को पूरा completely if you're going to fill with something, that is the volume. How much air is required to fill that room, or how much light means anything if you're going to fill it. So that is the volume of that. Okay, so space occupied by an object, solid body, is called the volume of that particular object, the solid. Okay, volume is always measured in cube unit. Okay, because here you are just not talking about the surface, you are taking the whole three dimension. Okay, so it will be in cube unit. Okay, now some important formulas that we are going to study, all the formulas of all the different shapes. Just a minute. Okay, cuboid. So when you're seeing a cuboid, so what is a cuboid? Cuboid is a three-dimensional figure of a cube. You can see here three-dimensional figure. If you see one of the surfaces, it is a rectangle. Okay, one of the surface that is here in this cuboid, all the six rectangles faces combine and make a cuboid. Okay, now what are in the cuboid here? You have a length in one surface. If you see here, okay, I'm using different colors so that it will be very clear. Okay, wait. Okay, now here the below one. Okay, I'm marking the six faces here. Okay, this one is the upper part. This upper one is the first one. The below one is the second. Now this is the third. This is the fourth. This is the fifth. And this is the sixth. Wait, this is the sixth face. Okay, so if we are telling that this is the length and this is the breadth, of course, this is the height. Okay, so if I'm talking about the surface number first, okay, the first one, the ceiling one. Okay, if I'm talking about your ceiling, so it will be length into breadth. Okay, the first one will be length into breadth. Similarly, if I'm talking about the floor, then also it will be length into breadth. Okay, but if I'm talking about the four walls, okay, if I'm talking about the four walls, your front wall and the back wall, this one, the front wall and the back wall, the third, no, wait, not third, I mark it with fourth and sixth, fourth and sixth. So this fourth and sixth, it will be what? Length into height. This will also be length into height. And similarly, third and fifth will be breadth into height. Breadth into height. Okay. Now, I'm talking about the surface area. So if you're talking about total surface area, that is TSA. So what will be TSA? You're going to add everything. Okay, so you have 2 LB, you have 2 LB, you have 2 LH, and you have 2 BH. Okay, so we can take 2 common, and LB plus BH plus LH. Okay, so this is your total surface area of a cuboid. Understood? Any doubt? And yeah, square unit. Always write square unit. Okay, so this is the total surface area of your cuboid. Now lateral surface area, LSA. Now what is lateral surface area? The lateral surface area means the area of the four walls. Okay, if we are talking about just the lateral surface area, we are not talking about the ceiling and the top. Okay, for example, I tell you that we have to make a room. Okay, how many bricks will be required? Okay, so you need to find out the surface area, but the floor will be made from cement and the ceiling will also be made from cement and rods. Okay, the iron rods, it will not be required bricks. Okay, only the four walls will be required bricks. At that time you are going to find out lateral surface area, which is just the four wall. So what is the area of your four walls if you avoid the ceiling and the base from here, this all? Okay, so it will be 2LH and 2BH. Again, HH will be also common, so it will 2, you will take out common, L plus B and H. So this is your lateral surface area. Okay, now if you're talking about diagonals, so diagonals will be root L square plus H square plus B square. Okay, and then last one will be the volume. No? Yeah, volume is similarly volume. How you find out the volume of a volume will be length into breadth into height. Okay, the how much complete area. Okay, so the complete volumes, that will be length into breadth into height. You are going to multiply all the three. Okay, now similarly, see, I have also mentioned for you lateral surface area is the area of four faces. Okay, now similarly everything is same for the cube. Okay, only difference is that instead of L, because in cube all the faces are equal. Okay, and length and breadth are also equal. It is the 3D form of a square. Okay, so here length, breadth, height, everything is equal to A or X, whatever. Okay, one thing only. Okay, so if we are talking about cube, so here length into breadth, length is equal to breadth into height is equal to A. I'm taking A, can be anything. Okay, now here also you have six faces. Okay, and the area of one face will be, area of one face is equal to A into A, which is equal to A squared. Total six faces. Therefore, what will be the surface area? TSA, it will be 6A square. Similarly, no, not TSA. So total surface area or lateral. So yeah, TSA, it will be LS. Okay, where I was. So TSA will be 6A square and LSA, lateral surface area, will be 4A square because only four walls will be included. Okay. Now diagonal will be what? From this point to this point. Okay. So diagonal will be same, root A square plus A square plus A square. Okay, so you'll get 3A square. Okay, so 3 will be in root and A square you can take out common as A, not common, it will be 3A. Okay, now what is anything? Yeah, volume. Okay, volume will be again L into B into H, so A into A into A, that will be A cube. Okay, any doubt in the formulas of cube and cuboid? Okay, now comes the right circular cylinder. Okay, now as you can see the figure. Okay, now first read this definition. Cylinder is a solid figure obtained by revolving the rectangle, as I said in the starting. Okay, now here in the figure you see ABCD. ABCD is a rectangle, and making BC as your fixed, if you are going to revolve from AD side, okay, around a circle, okay, so that will form a cylinder. Okay, understood? Or you can say, if you are going to enlarge your circle, okay, you take a base circle and a top circle, and then you are going to join from lines. Okay, so that is also, you can say, a cylinder. Okay, so here in cylinder, since you can see the base, it is in a circular form. Okay, so here R is there, we can see this, the radius here. Okay, this is R and the height is H. Okay, now here curved surface area, the curved portion surface area, TSA, that is the total surface area, and volume. Okay, all these three will be there. Now what will be the curved surface area? in the cylinder, the curved surface area. Now, in cylinder, you will study two types of cylinder. This is the right circular cylinder, okay, and the right circular hollow cylinder. Hollow cylinder means from inside it is empty, and from it will be a like ring. If you take a ring, okay, and you make a 3D of ring, okay, so that is a hollow cylinder, okay. Now, come back to your right circular cylinder. So in right circular cylinder, the curved surface area, that is a CSA, in short you can write, that will be equal to the circumference of the base. Okay, circumference of the base. What is the circumference of the base? That is 2 pi r, okay, and into height. So what is the height of your circular cylinder? We have taken here h, so it will be h. So what it will be? 2 pi r h, okay. So it will be 2 pi r h, your curved surface area. Okay. Similarly, total surface area. If you are going to take the total surface area, so it will be curved surface area plus the base and plus the top. Okay. So the curved surface area plus area of the two ends, that is the top and the bottom. So what it will be? Curved surface area is what? 2 pi RH. That is your curved surface area. Now, what will be the area of the base and the height? The base and the top. It will be pi r square. Now, 2 are there, pi r square plus pi r square. So, you will get 2 pi r square. Okay. You can see here. So, TSA of cylinder, it will be 2 pi r h plus pi r square plus pi r square, which will be equal to 2 pi r h plus 2 pi r square. Okay, now you can take 2 pi as common, 2 pi r as common, and h plus r will be there. Okay, understood? So you have to remember all these formulas. Okay, it's very important. If you're going to remember the formula correctly, you will not make mistakes. Okay, and the other mistake that you can do, that is your calculation. So you keep on practicing with the calculation, and then you're not going to, especially if you learn the tables. It's good that if you learn the table till more than 20 or at least till 20. Okay, so in that way calculation become very easy. Okay, now the volume of the cylinder, how much thing it is going, that this cylinder is going to keep inside. Okay, or how much amount of thing we can keep it. Okay, so the area of the base, okay, into height. Okay, so what will be the area of the base? That will be pi r square, and height will be h. Okay, so pi r square h. Okay, understood? So this is the volume of the cylinder. Okay, when we were taking curved surface area, then we were just taking the surface area. So at that time, circumference of the base into height were taken, and when we are taking volume, so it will be area of the base into height. Okay, so that time 2 pi r h, and here volume pi r square h will be there. Okay, now right circular hollow cylinder. Okay, now here you again have a cylinder, but cylinder inside cylinder. Okay, and you're keeping a bigger cylinder, you're having a bigger cylinder, inside that you are keeping a smaller cylinder. Like you have a ring, you have seen the ring. So in this ring, if you're going to take the three-dimensional of the ring, okay, if you're going to expand this ring, okay, so this is only a hollow cylinder. Hollow means empty. So inside it will be empty. It will be in form of ring. The thickness may vary. Okay. So here you, since it is a hollow cylinder, so there are two cylinders inside one another. Okay. So there here two radius will be there. One radius of the smaller cylinder, the inside cylinder, and one radius of the thicker or the other can say not bigger, the thick one. Okay. The outside cylinder. Okay. And the height will remain the same for both. Okay, now let's see the curved surface area, the total surface area, and the total surface area and total outer surface area. So many things will be there, and volume. Here in volume, if you're taking the volume, so inside will not be counted. Now, curved surface area. So when you're finding the curved surface area, so we already know the curved surface area of a cylinder. What it is? 2 pi r h. Now, when you're taking the curved surface area of a hollow cylinder, then you are going to add up the curved surface area of the outer cylinder plus the curved surface area of inner cylinder. Okay, so there's nothing much complication. Only you will be having two different R, that is 2 pi RH. You'll be having 2 pi RH plus 2 pi RH. Okay, so you can take 2 pi H common and R plus R. Okay, so this is your CSA. Okay, now let's see the total surface area. Now, when you are seeing the total surface area, what was the total surface area in case of your cylinder, normal cylinder? We were taking the curved surface area of the cylinder plus the area of both ends. Okay, so here also it remains the same formula, curved surface area, but here curved surface area of hollow cylinder plus area of both ends. Okay, so area of both ends will be pi r square, but here there are two different radius. Okay, so TSA in TSA, curved surface area CSA plus area of two ends. Okay, so which will be equal to curved surface area of hollow cylinder will be 2 pi h r plus r. Now, if you take the surface area of two ends, so it will be what? It will be pi r square plus pi r square. Okay, so you can take pi as common. Okay, pi common, and then it will be r square plus r square. Okay, understood? Any doubt? Just a minute. 2 pi, wait, it is okay. When you are taking the surface area of upper one and the bottom one, it is in the form of a ring. It is in the form of a ring. Okay, so we will take this portion only. Okay, this portion only we are going to take. So if we are going to take this portion only, so what it will be? It will be minus here. Okay, it will be minus here, and then you can have a formula 2 pi h r plus r plus this will be r a square minus b square. So a plus b and a minus b. So it will be what? You can take again common. So it will be 2 pi r plus r. Okay, and h plus r minus r. Okay, square unit. Okay, so this is your you can say a total surface area. Okay, I'll mark here also. Yeah, curved surface area. This is the curved surface area, and total surface area. This is your total surface area. Okay, now total outer surface area, just the outer one if you're taking out. Okay, so it will be, you don't have to go with inside one. It will be 2 pi RH, the capital R, which is of the bigger one, and below just the ring one you are going to take. So 2 pi r square minus r. Okay, now any doubt till here in any of the formulas? These formulas are very important. Okay, before the next class, remember the formula. Okay, you are going to have 3 days. Okay, so remember all the formulas. Now, volume of the hollow cylinder. When you are taking out the volume, so the inside one, you're not going to put anything inside that. Okay, if you're going to fill a hollow cylinder, so everything will be filled inside this. Okay, things will be filled inside this. Okay, so you're having pi r square h. Okay, the base area. Okay, 2 pi r h. Okay, so volume of the outer cylinder minus the volume of inner cylinder it is. Okay, so what will be the volume of outer cylinder? We have seen the volume of a cylinder. What is the volume of the cylinder? Pi r square h. Okay, because it is area of the base into height. So pi r square h, and for the inner also pi r square h. Okay, so pi will be common and r h will also be there. Okay, h will also be there. Just a minute, I'll just do the change here. Nobody has any doubt till here now. So it will be pi r square minus r square h. We have taken the common outside. Okay, you can just write pi h r square minus r square. Okay, now sphere. What is a sphere? The ball, the football that you have been playing, or any type of ball you must have seen. Okay, so that is called a sphere. Okay, in a circular form. Okay, the three dimension of a circular. Okay, so sphere is a solid generated by the revolution of a semicircle about its diameter. Okay, let radius of the sphere be r. Now here, what we have assume that the radius of this sphere is r. Okay, understood? Now, what will be the surface area of the sphere? The surface area of the sphere is 4 pi r square units. Okay, 4 pi r square unit, and the volume, yeah, volume of the sphere is 4 by 3 pi. Here you are having 4 pi r square. Okay, and when you're going for volume, it will be cube. Okay, but here 4 by 3 pi r cube. Okay, here if you go with derivation, so it is a little tricky. We use means integration and all. Okay, so just remember this formula as it is. Okay, so volume of sphere, when you will go in higher classes, then you will learn about integration on 4 by 3 pi r cube. Okay, and the volume of hollow sphere. Okay, now here this is a different part. Okay, now these two are talking about a simple sphere. Okay, a sphere, a solid sphere. Okay, so there can be a solid sphere, a hollow sphere. So this portion is of solid sphere. Okay, and this is for the hollow sphere, the last one. Okay, so if you're talking about the solid sphere, so the surface area will be 4 pi r square units. Okay, and the volume of the sphere will be 4 by 3 pi r cube. Understood? Now, if you're talking about a volume of a hollow sphere, so it will be, again, it will be a hollow inside. So there will be two radius. Okay, so for the formula will remain this only, but instead of r, you'll have two r's, capital R for the outer one and for the inner one, small r. So 4 by 3 pi r cube minus r cube. Okay, that's it. Now, hemisphere, similar. Hemisphere is just the, if you are going to take a sphere and cut it into half, then you'll find you'll have two hemisphere. Okay, now a plane passing through the center cut the sphere into equal parts. That only I explained you. Okay, it's called a hemisphere. Now, again, it will have a radius r. Okay, now curved surface area of a hemisphere. So what was the curved surface area of a sphere? It was 4 pi r square, and hemisphere is just the half of sphere. So it will be 4 by 2 pi r square. So it will be 2 pi r square. Okay, now total surface area of a hemisphere. Now here thing changes. Okay, so it will be CSA of hemisphere. Okay, CSA of hemisphere plus area of one end. Okay, because you'll have one base and then half of the circle is below. Okay, so CSA of hemisphere, so curved surface area of a hemisphere is what? 2 pi r square plus area of the one end, this circular end. Okay, this is the, just a minute, I've used different colors. This area of one end. Okay, understood? So what will be the area of this? Pi r square, because it is a circle. Okay, so you can get 3 pi r square unit. Okay, so the total surface area of the hemisphere is 3 pi r square. Okay, when you are taking, when we previously in the solid object like cube and cuboid, like we were taking LSA. Okay, lateral surface, curved surface area is something like that, or you are taking just the curved one. Okay, not the base one. But when we are talking about the total surface area, we are including all of them. Okay, so CSA, the curved surface area plus the top one, area of one end. Okay, so 2 pi r square plus pi r square, you get 3 pi r square. Okay, now volume of hemisphere. Again, what is the volume of your sphere? It is 4 by 3 pi r square, pi r cube. Okay, so similarly 4 by 3 multiply, we are going to divide it by 2, so you'll get 2 by 3 pi r cube. If you are going to remember the formula of sphere correctly, you will figure out the formula of hemisphere. You're just going to do half. Okay, only the total surface area you have to remember, because here total surface area is curved surface area of hemisphere plus area of one end. Okay, now right circular cone. Okay, you must have wear birthday caps when you was a child. Okay, so it is, that shape is called a cone. Okay, a circle at the base. Okay, a circle at the base, and you have what you can say, lines from all that circle are you are taking a line in the upward and joining it at a point. Okay, a single point. Okay, if you are clearly if you are properly defining it as an English definition, it is a right circular cone is solid generated by revolution of a right angle. Okay, you can see here it is forming a right angle here. This is a right angle. Okay, if you're going to revolve this right angle into a circular portion, okay, in a circle, okay, you are going to make AO as fixed, and then you are going to revolve. Okay, this the right angle, you're going to keep this is a right angle, and you're going to keep this as fixed, and then you're going to revolve it. Okay, so what you can do, you can have a paper triangle, right angle cut paper. Okay, and then fix it at some place and try to revolve it. Okay, उस पोर्शन पे पकड़ के आप रिवॉल्व करोगे तो क्या होगा, एक कोन बन जाएगा. You'll get a cone. Okay, that is a cone. Now here, what are the different things? Here, the base, this is your radius. Okay, now this is your height. Okay, now in cone you'll get here as this hypotenuse is L. Okay, now what is the value of L? We already know in a right angle triangle. How do we find out this value? It will be root r square plus h square, because L square will be equal to h square plus r square. So L will be equal to root r square plus h square. Okay, so this is the L here. Okay, now the slant height of the cone, L I have already told you. Okay, the this is the slant one. Okay, the hypotenuse. Okay, so that is your L, and that is root r square plus h square. It is nothing special. It is just the Pythagoras theorem we have applied, because that is just the if you are going to move a right angle triangle into a circular portion, then we get a cone. Okay, now here, what will be the curved surface area? It will be pi r L. Okay, pi r L. Understood? This L will be there. Okay, so pi r L. Now total surface area will again be curved surface area plus area of the base. Okay, whenever you are finding lateral surface area or the total surface area, sorry, whenever you are finding the total surface area of any of the object, then you are going to, if you are having cube and cuboid, so you are going to add the base and height in the lateral surface area. Okay, and when you are having circular objects, okay, circle, hemisphere, cylinder, so what you are going to do, you are going to add the base and the height, or in many portion only base, where height is not, the top is not there, so area of the base in the curved surface area. Okay, so if you remember the curved surface area, and for time being you don't remember the total surface area, so you can find out the total surface area. Like the total, what will be the total? If you remember, only the curved surface area of the cone is pi r L. So what will be the total surface area of the cylinder, of the cone? It will be curved surface area plus the, because you are having only one cover here, the base one. Okay, so the base, the area of the base is a circle, so what it will be, pi r square. Okay, so pi r L plus pi r square. Obviously you are going to take pi r as common, so L plus r. Okay, similarly volume of the cone is what, 1 by 3 pi r square h. Okay, 1 by 3 pi r square h. Okay, now I'll not just start the numericals. Now we are going to deal with the numericals only. Okay, in the topic 1. Okay, no more theories are there. Okay, but before starting the numerical, I want that you remember all the formulas. Okay, so do you face any doubt in any of the formulas of your cube, cuboid, cylinder, sphere, hemisphere, hollow cylinder, cone? Any doubt? Today you sit and remember all the formulas. Okay, and your next class will be on Tuesday. Before Tuesday, you learn these formulas. Okay, Safia and Rudronier, any response? Yes or no? Something you can say.
Yes.
Okay, so learn this formula, and then we will be, because you'll not face, if you remember the first, nothing is there, like the first question. Okay, just see the first question, what it is here. We are seeing the combination, there will be very, here we are just seeing the combination of two or more than two figures of same type. Okay, same type के objects, जब आप same type के आप figures को जब join कर रहे हैं, तो in this the question, simple question is here, 3 cubes each of side 5 centimeter are joined end to end. Now cube, you will just need one measurement, that is A. Okay, so it is given that is 5 centimeter. Now we have joined three cubes side by side, as you can see the figure. Okay, so now what you get if you're going to join three cubes side by side, so actually you can see I have got a bigger cuboid, okay, whose breadth is 5, height is 5, and the length is 5 into 5, 5 plus 5 plus 5. Okay, so L becomes here 15, breadth becomes here 5, and height is also 5. So simply what we need to find out, find the surface area of the resulting solid. So surface area will be what? Surface area is what of cuboid? It is 2 LB plus BH plus LB I have written. So it will be LH. Okay, you just have to put the values and you will get the answer. Okay, so it be where L is there, so 15 into 5 plus just 15 into 5 plus 5 into 5, okay, plus 15 into 5. Okay, and you're going to solve it and get the answer. That's it. Okay, so if you remember the formula, nothing much is there. Okay, that's why I'm asking you to remember learn the formulas. Okay, so we'll meet in the next class, that is on Tuesday, and try to prepare your ARP also in the upcoming week or the next week. I'm surely going to take